Right, so today I'm going to review this thing from FNIRSI. Yeah, assuming that's how you pronounce it, I don't know. This is sent to me at no cost for a purpose of review, so thanks a lot FNIRSI for sending that to me. Let's have a look and see what we're dealing with. So, this is a component tester thing. It's a transistor tester. Apparently it's got Zenas as well. I haven't read the manual. Is there a manual? And we'll see what we've got. Let's see. Oh, we do have a manual. Got some little clip leads. USB-C to A cable for charging it. Oh, okay. Didn't know it did that. So it's got interchangeable tops, so you can do surface mount parts. That's actually a nice feature. Now let's have a look inside here. I don't actually know very little about this. This is something FNIRSI actually suggested I have a look at it. So I went, yeah, okay, let's have a look at it. They wanted to send this to me because I showed another unit very similar to this before, which was there's another unit which I've forgotten the name of right now. I'll overlay it or something, which I was looking at before, and this is similar. In fact, it does transistor testing, but it's got a mode switch here for infrared or transistor, test button, Zener, high voltage button. So it's the LCR-P1 in case you didn't realise what it was. You can read this yourself in your own time. But it's got a 4.5 volt voltage drop for diodes. It means you should be able to do LEDs with it. Voltage regulator diode up to 32 volts. Does FET. MOSFET. What's this? Bit of a typo there for FNIRSI. What's that? And that's an actual device that I don't know about. Is that MOSFET or is that something else which I don't actually know exists? It could be that I'm not knowledgeable and I'm missing something, but to me that should be MOSFET, should it? I don't know. SCRs, okay, capacitors, resistors, inductors, can measure batteries. Interesting. Infrared remote control decoding, that's quite an interesting feature. That's useful. I should read this before I actually do the video so I know to use it. And it's got a firmware update option as well. Okay, infrared decoding. That looks like a nice thing. Like I said, that's useful. Okay. So the first thing that grabs my attention is the fact that you can pull this off and install another one. Okay, so I can do service mount stuff, that's nice. I might get some service mount parts and chuck them on there. No, yeah, that's fine. That plugs in nicely. Cool. Flux residue on the back of that, not much. It's only slight. Would have been nice if they cleaned it off. But that's just me being fussy. We'll start off testing a transistor. This is a 2SC945, nothing too exciting, it's a basic sort of thing. This is used a lot of older CB radios. I've got loads of these things. Drop that in there. Test button, let's turn it on. There's a screen, version 102. Do a test. It's taken a while, but I did identify NPN transistor. What I'll do is I'll get my transistor tester out and I'll see what this compares as. Let me get that. Peak DCA 75. So we've got these details here, which hopefully will stay on screen a bit longer. We'll hook this up and we'll see how they compare. I mean, there's no 100% right rule for these things, there's always still a bit of variance between them. Anyway, let's see what we get. So, oh, this one's gone off, now we can't see it. It's a 247 HFE, I can't remember what that one said, I'll have to see it on screen when I go back, actually I might just retest it. So 247 HFE, forward voltage 0.75. Okay, so this one gives you quite a bit of information. Gives you quite a lot. This is a really good unit, but much more expensive than this thing. Alright, so 247, that's what I look for there. And I'll retest this again on the FNIRSI. So I might have to just look at how I do this as far as timings. Obviously it doesn't stay on forever. So I've got 247 on this one. And it says 236. That's pretty close, that's not bad. In the ballpark. This is a 7812. Well, I think it says it can do a voltage regulator. I guess we'll just about to find out. Can it or can't it? I might have to do this high voltage thing. No, do the high voltage thing. That's now on. Let's try this again. Nah, can't identify it. So that's not surprising though. Regulators, not surprising. Let's look at something else. Over here I've got some more transistors. These are FETs. Put one of these in. See what this thinks of it. NPN transistor. Didn't detect its effect. HFE 111. Okay. 652 VN. Alright, let's hook this on the peak and see what the peak thinks of it. I think these are fed. I'm pretty sure they are. Look at the number in a minute. See what this thinks of it. This is NPN as well. 141. So this is slightly higher. There could be the test current slightly higher. I think they said, did that say? This is 1 amp. Yeah, it says 1 milliamp there. And this is doing 5 milliamps. That's probably what the difference is. Different current, so it's affecting that. And 786 there and getting 652 there. Again, could be because of different test currents. Okay. What is this device anyway? Let's have a look, find out what it is so you know what I'm talking about. That's marked as 72418D. I've got no idea what that is. I don't remember. Yeah, I don't know what those are. I've had them for years. LED. This is doing the normal tester part between 1 and 2. See what happens. See the flashing. That's doing that much. Diode. Yep. Okay. 2.75 volts. Now it's got the anode cathode connections. Let's shove it in there too. See what I think of that. I think I put it in backwards. Yeah, I think I put it in backwards. Turn it around. No. So I identified it in like 1 and 2, but I didn't identify it down here. I'm probably using it wrong. But yeah, okay, that's at least work with LED. You see it flickering and it did actually identify it. This is an interesting one. Let's just shove that in. Let's go between, was it 1 and 3? See that flicker in? There you go, red LEDs. It shows a resistor, 47 mega ohm. That's interesting. Let's do a test again. And again, 51 mega ohms. Not quite right. Let's try these other pins again, just in case it matters. Maybe it'll work this time, maybe it won't. No. So, in that case, it was a bit of a struggle for it. I don't know why I couldn't identify that one. I don't know if this can identify it, so I don't know if this can do it. So that's flickering away. And it's identified as an LED, 1.8 volts forward voltage. So this one can identify it. This struggled a little bit. Okay, let's look at something else. Inductors. It's a 10 microhenry. See if we can figure this out. Inductor, yep, between 1 and 2, correct. 10.8 microhenry, that's not bad. It's close. Let's do a 470. .446, not bad. It's close-ish. Let's actually use a pop LCR meter and see what we get. I'll just tell you what they are. So we've got 446 on this with 5.7 ohms. Inductance are getting 477 at 100 hertz with a ESR 5.4 ohms. Let's say 5.7, so that's actually pretty close. Let's change frequencies on this and let's see what we get. So 8 kHz get 426, 422 at 10 kHz. So I'm not quite sure what this is actually used. Maybe I should probe that, I'm not sure. But anyway, that's that one. This one should be a little bit more of a challenge for it. This is 1 microhenry. Let's see how this goes for it. It may or may not be able to deal with it. It's pretty small. So this is 1 microhenry, this one. Yep, it measured it. It said it's 0 though. Okay. Let's try something slightly bigger. Let's go to a 3. So this is 3.3, I think it is. It's also measuring 0. Okay, let's try some pins which are closer together. No, it still returns 0. But it knows it's an inductor, so it's kind of there, but it's not giving the right value there. So it's like it's really small inductances it doesn't like. Okay. Alright, let's test this thing with some diodes now. This is Zener diode. Let's try this. Let's go between 1 and 2. This is an 18 volt Zener. It's identified as a diode at least. Let's do it in the actual diode positions just here. Do a low one first. There we go. 18.24 volts. That actually works. Cool. So that's in the anode cathode pins in the Zener diode mode. So that's excellent. That actually works. And if I took this in backwards, does it still work? That's what we need to know, isn't it? It does. It still works. But it says reverse and gives you the forward voltage instead. Cool. It actually does a nice job. Let's do a lower voltage one. Let's do a 5 volt. Turn the Zener mode back off again. We'll try it. So I want to see what happens first. No, okay, Zener mode, turn it on. There we go, 5.37 volts. So that's fine. This is supposed to be a 5.6 volt. So that's actually right. It depends on the test current. The higher the test current, the higher the voltage will set. So that's working fine for those. We should try a TRIAC. What do you reckon? Now this part is a BTA 26800BW. Comes back as a resistor, 55 ohm. Okay. Now I actually have a tester here for these. Let's hook onto this and see if this can identify it. Yeah, they found a TRIAC. Told it to pin out. Yeah, so this can identify it. So there's nothing wrong with the part itself. It's just this isn't suited to this particular part. Now I do have some other ones in here. Let's give it a fair chance. I've got another one. Let's try this one. BTA 24600BW. Found a resistor again, 70.8 ohms. Maybe I'm doing something weird. Let me check the manual in case there's a certain way to test these. Maybe I'm doing something wrong. Well, this doesn't actually mention any specific testing function for SCRs. Well, it says it can do them. It's in the list. Mentions them here. But there's nothing special about the way you test them, so I don't know why it's not doing it. Maybe it's this particular device it doesn't like. Could be the voltage for the gate threshold is too high, so it can't detect it, something like that, maybe. I don't know, I'm just guessing. But not those ones. Okay. Right, next test. It's testing capacitors. Now, this may be challenging for it. In fact, I might even use my LCR meter again, which is on my desk here. Got the Peak ESR70, which is a really good capacitor tester. This is good for also in circuit use too. It's really handy. You get pros and cons between different devices. This is much more expensive than this for a startable, but this can do in circuit. This obviously can't because it's form factor. This is a much more expensive device than this, so that's a trade-off. You pay a lot more. So let's test various capacitors. This one here I know is completely dead, so it'd be interesting to see what it says about that. I've got some other ones here. I can't remember what they actually are. What I'll do is I'll check on my bench LCR meter first, and then I will look at them on here, and then we'll look at them on the peak. And on the bench LCR meter, I'll just tell you what they are. And you can just have to trust me. Well, I'm not lying to you. How's that? Okay. Let's do this little one first. Let's have a look. Frequency is currently at 10 kHz. And I like to test electrolytic capacitors at 100 Hz. But for argument's sake, we'll do 10 kHz first on this capacitor, then we'll do 100 Hz, which is where I like to normally test it. Okay, so this one's measuring 5.8 microfarad at 2.2 ohms at 10 kHz. And if I change the frequency down to 100 Hz, I'm getting 17 ohms at 7.5 microfarad. So 2.2 at 10 kHz, remember that. So it's measuring 2.62 at 7.5. So it's giving the 100 Hz capacity, but the 10 kHz ESR, which is interesting. The 100 Hz capacity is going to be a more accurate one, by the way. And, oh, shall I tell you what this capacitor actually is, shouldn't I? It's a 6.8 microfarad. These capacitors may or may not be good. I have a big pile of capacitors here, things which I pulled out of equipment when I'm doing refurbishment. Some are good, some are bad, mostly bad. That's a 220 microfarad 10 volt. We'll see what we've got in here. It is a bit slow to test, but it does seem to work okay, what I've seen so far. 2.21 at 231 microfarad. On the bench LCR meter it says it's 206 microfarad at 3.3 ohms. So it's close. I'll check it with these ones afterwards. I'll just do these two devices first, otherwise it gets a bit confusing. Check this one. What's this? This is a 50 volt 47 microfarad. It says 47 exactly, 1.55 ohms. Bench meter says 43 microfarad at 2.6 ohms. So this is metering lower again. It says 34 at 8.6 ohms. And this is a 47 microfarad. I think it's easier to do this one first because you can actually see it on screen as well whilst I'm reading it out. So it said, was it 34, 8.6, wasn't that what it said? This is measuring 47 at 2.3. Interesting, so this is giving different results to my bench LCR meter. The capacity matches what's actually marked on the capacitor, which is interesting, although the bench one is saying something different. So this one here is a 35 volt 470 microfarad. It says 484.37 ohms. That's actually looking like a reasonable capacitor. It could be. And the bench meter is saying 440 microfarad at 3.35. So the ESR is very close. The capacity again is different. So that's interesting the way it's getting. It seems quite generous on the capacity ratings, what it's saying there. Let's do this one. We'll almost get to the end of these capacitors and I'll do them on here and see what we get as well. 151 at 0.44. So the capacity's up by quite a bit there. And on this one we're getting 141, which is also reading higher, and at 0.9 ohms. So okay, capacity's higher on this one, but my bench LCR is saying almost double the ESR. And the last one here, which I know is bad, it's just 2 picofarad, nothing else, which is what this capacitor is returning on just about everything. It's returning basically open circuit as a picofarad capacitor. This one is completely dead, so that is fine. That not measuring this one is exactly right. That is absolutely knackered. So let's just look at the peak meter and see what we can get out of this one. A bit harder because it's got probes instead. Let's just stick on the sides of this one. Can't even see it. Can't even see it. Do a manual test. Nah, see that compares. That's completely dead. Can't see that one at all. Okay, next one. 140, remember got 141 on the other meter and 0.9 ohms. This one's got 0.81. So this is higher than what the other meter said, what the FNIRSI said. So the FNIRSI said 0.4, didn't it? And 151. This is more close to my bench LCR meter. So here's 36 and 4.6. Again, this was different to what this said. And basically matches my bench LCR more closely. Get it probed properly. I'll do it twice. Didn't probe very well first time. You know, 44, 1.55. Again, this is reading a little bit different. Next one. 206 and 5.8 ohms. Again, it's close to what my bench LCR meter said. To confirm these are matching. So 2.6 and 7.2. I mean, this is close. It's ballpark. It's not perfect though. I think once you get used to using it, it'll probably give you a good enough indication to say yes or no. So it says 450 at 0.38. If you're using this thing all the time, and this is what you're normally using for testing your silent capacitors and stuff like that, you would get to learn, like you get a feel for it, and you get to know whether it feels right or not, whether it's actually, whether 2 ohms is good or bad for you. It depends a lot on your meter. You have to get familiar with how your meter responds and how it behaves, and how they work, basically. This uses 100 kilohertz or so in order to do in-circuit testing, whereas obviously this doesn't do that. Okay, well, it's at least showing relative changes. Capacity looks good. ESR does change, and it is relative to the health of the capacitor. So if you know that 2 ohms on this thing is not great, then you know your capacitor's bad. It's a case of learning your equipment as well. So I mean, it is working. Now let's look at this board here. This surface mount board. We'll drop that in and try doing some surface mount parts in there, see how hard it is to do it, or easy it is to do it. Drop that in. Got a box of surface mount parts over here. This is a 4007 diode. So it should be a 4007 diode, so it should be 0.6 volts or so drop. Can't see it. Okay, let's do it across here instead then. You would think it would work. Let's go across here instead. There we go. 0.67 forward drop. That is a dedicated one for the diode. Yeah, that's really meant for Zeners, I think, that one there. So I did it across those two, and that's obviously where it worked. I probably could have done it across those as well to work because I worked. Right, so that's a 4007 diode, no problem there. Let's try a 4148, which is going to be a bit trickier because it's not really right form factor. This is a MILF diode. But hopefully I've got enough sticking off the end I can actually get it to touch the circuit. Let's try it. Here you go, 0.68, that's working. Let's try a transistor. This is a 2N3904. Can you see it? I might need a tweezer on this one. So here we go. Try and get it across all three connections and held down. Let's try it. About there. Try that. There you go. I got it. So that's correct. MPN 182 sounds about right. And also got some 3906s, which would be PNP. Not sure I've got it on there yet, we'll see. Yes I do. PNP. That one tested quite quickly, it's interesting. That one tested much faster than the MPN did. And 186. Yep, that sounds about right too. So that's good. Have an IRF something. IRF 9530. Let's try that. And probably get across it okay, hopefully. Yep, there we go, MOSFET. That detected that just fine. So I've just got a tantalum capacitor here. Let's see if this can read it. Tantalums will give you different readings as far as ESR and stuff. They do tend to be a bit different. So that's 9.6 microfarad, 0.73, so it's probably a 10 microfarad. Let's run random inductor. I don't know what the value is offhand. I can probably measure it on here. I will have it noted down here somewhere, I'll have to look it up. Inductor 3.2 ohms and 361 microhenry. Actually, that sounds alright. That's a 330 microhenry, so it's about 30 microhenries higher than I've actually measured previously. Just for completeness, I'm going to measure these capacitors at 10 kHz on my bench LCR meter here. So this is measuring 0.21 ohms on this big cap here, which was the 470 microfarad 35 volt. This one here is a 47, I think it's a 47, 50 volt. That's measuring 1.35 ohms. 33 microfarad, 5.7 microfarad and 2.4 ohms. This one here is 62 microfarad, 3 ohms. So these are closer to what this was saying at 10 kHz. This is measuring 4 ohms, 11 microfarad. And so just like the capacitance reading of this is more in line with the 100 Hz frequency test, but the ESR is more in line with a 10 kHz frequency test. So that's something to bear in mind. It's sort of like a best of both worlds in a way, I suppose. Because the higher frequency is the more standard way of doing it. I use 100 Hz because it gives a more obvious reading. So this one here is measuring 68 microfarad and 0.32 ohms. And this one here, as I said, doesn't show anything. I don't know, well, maybe I'll reference it later on, put the chart together. Now I've got the measurements all recorded. So you can do comparison between this one, that one, this thing, a couple of different frequencies. Maybe I'll do something like that. Put it together in a chart or something. So you can actually see visually how it looks. If I do that, I'll put it on screen. It'll be on screen now, maybe, if I do it. So the next test, let's look at some resistors. You haven't done that yet. So I've got some here which are marked as being less than 1 ohm. I don't think I've got any loose ones, so I'll do. Yeah, 0.22. Let's get 0.22. Let's measure it with the LCR meter first. See what we get here. So the LCR meter is saying 0.208. Let's see what this says. .4. So it's probably too small a value, but I mean it is measuring it's less than 1 ohm. No, maybe there is no calibration menu. Maybe it's not possible to calibrate. And maybe there is a way of doing it, I just don't know what it is. Okay, let's do 30 ohm. So this is 30 ohm here, or so. It's measuring 30.3 ohms. Now normally resistors, if you touch them for too long, you heat them up and that will actually affect the resistances. But I'm trying to avoid doing that as much as I can. 31.1. 1 ohm out. This is supposed to be 600 ohm. It's measuring 604. .615, so it's 10 ohms out. These are some 5.6s, 5.6k that is. That's measuring 5.61k. 5.68. So still like 70 ohms out, but when you're in k's it becomes a negligible amount of difference, but reasonable. It's in ballpark. Which is supposed to be 100k, getting 98.99. 95.3, so that's 4k down, and that's quite an error really. Now seeing as the errors seem to get worse at 100k, let's try these, which is a 390 or so. So we'll get one of these. That's measuring 406, 406.6. 404.9, so it's actually not too bad, it's only 2k out. That's just doing slightly better. Interesting. Now I thought let's try some different capacitors. So it's a 10 nanofarad capacitor. See what we can think of this. See if we can measure a capacitance this low. It says 9 nanofarad, it can do it. Okay, let's try another one. Let's try 1 nanofarad. This is a green cap, it's a bit different. .982 picofarad. It can read that too. Let's keep going. This is a 100 picofarad, ceramic type. You get to a point where straight capacitance becomes a problem. 95 picofarad. You can read that, that's good. This one here is a 10 picofarad. I really expect straight capacitance to be a problem now. 9 picofarad, you can see that too. That's actually quite good. This one's a 3 picofarad. 3.3 in fact. It says 2. I mean it's 50% out, but you can see it. That's actually surprisingly good. Let's check the infrared decoding. Flick the switch up here, we'll turn it on. Got a remote control here for my aircon, may or may not work. Let's do it. There you go, decoded it, cool. That's the code for the power on, address code and command code. I'll do it again. Same codes, I'll do temperature difference. But the code's just giving it the same. Yeah, they're not changing. Which I'd expect it to change if you're doing a different function. It does detect an infrared at least, so you can see something there. And it does give you some codes. I think I need to get another remote control. Okay, now the remote, and it just turned off. That's annoying. Turned off a little bit too quick. Right, let's try this one. Pushing different buttons is giving different codes. So that's actually working better then. So this is actually doing it right. But seeing the other one wasn't doing it. That's a handy feature if you're trying to test a remote control. That's good. So it looks like the infrared sensor is actually down here behind this little grill there. If I push this right down here, that's when it changes. Put it anywhere else. No. Down here is where it seems to be. In case you're wondering where it is. Well, it seems to be working basically okay. It does the things it seems to be supposed to do. The only thing I wasn't sure about is the SCRs and TRIACs. I mean, I did TRIAC, which I think it's kind of the same thing as an SCR, isn't it? I'm not quite sure. Actually, I'm not really have much experience with them. Yeah, it's one thing I wasn't quite sure about there. Everything else seemed to work okay. Just checking some of these specs here. It says capacitors is 25 picofarad upwards. Well, we got down to like 1 picofarad. You know, was it 3.3 we got down to, and it's measuring that, so that's actually quite good. It does okay. It's actually alright. So there's only one thing here which I thought was a bit dodgy, say the SCR thing, TRIAC testing. But then those are notoriously hard to test, so that's why I've got a dedicated tester just for doing that, because they are hard to test. So it doesn't really surprise me it struggles a little bit, that one. But the rest of it seems alright. This little board's handy. That'd be good for surface mount stuff. You know, you can't get in the clip leads or surface mount stuff all the time. Sometimes you can, but sometimes you can't. So that's good for that. ESR measurements were in line with what I kind of expect for a 10 kHz test. So ballpark maybe slightly lower than 10 kHz. Does tend to read a little bit on the lower side. A bit more generous, I suppose you could say. But again, it comes down to your equipment. If you're used to using this all the time for doing that kind of testing, you're probably used to it and get to know what to expect. It is actually showing a difference, at least, where some other testers, not so much. But this one seems to be doing something in line with what it should be doing. So that's good. So thanks a lot for FNIRSI for sending that through to me at no cost. And check the links out down below. The links to FNIRSI's site, I don't know, AliExpress pages, something like that probably. I don't know. There'll be links down below. Go and check this thing out. Check out my other videos down below. Subscribe over here if you're not already subscribed for more review stuff. And the Patreon support link over there if you want to support me. A couple of dollars a month. And it helps the channel. Catch you later.